Parallel and perpendicular lines. So parallel lines, two or more lines are considered parallel if they have the same slope and different y-intercepts. So with parallel lines, the important thing to remember is that parallel lines will never intersect each other. They never cross or touch. And the reason they never cross or touch is because they both have the same slope. The f of x has a slope of 1/2, and g of x also has a slope of 1/2. And so if you think of this being in a race, if you are racing somebody else and they're in front of you, if you are running at the same pace, the same rate, that means you're never going to catch up. You're never going to be even with them, and you're never going to surpass them either. So if we look at these slopes in like a rise over run kind of way, this guy has a rise of 1 and a run of 2. At the same x value, red line also has a rise of 1 and a run of 2. So since these are both changing at the same rate at every coordinate, that means that the red line will never catch up to the blue one. Parallel lines have the same slope and they never cross or intersect. Perpendicular lines, so two lines are perpendicular if they have what we call opposite reciprocal slopes. So what that means is opposite reciprocal means opposite sign and flipped fraction. So if both of these things happen to your slopes, that means that these are perpendicular lines. So if we look at the slopes, so the blue line has a slope of 1/2. And if I make a perpendicular slope to that, that means I'm going to change the sign. So this positive becomes a negative slope. And then I'm also going to flip the fraction. So if I flip over 1/2, that becomes 2/1. And I can simplify that even further to just a plain -2. And if I look, that is exactly what the slope of the red line is. And so the red line and the blue line are said to be perpendicular because they have opposite reciprocal slopes. This 1/2 and this -2 are opposite signs and the flipped fraction from each other. On their graphs, these guys will always intersect at 90 degrees. So perpendicular lines will always cross each other at 90-degree angles. So just because lines cross doesn't mean that they are perpendicular. For example, this line and this line cross each other, but none of these angles are 90 degrees. So these are not perpendicular. Same thing with like this line and this line. Those are not perpendicular because they do not cross at 90 degrees. So classifying parallel or perpendicular lines. So here are the keys. Parallel lines will always have the same slopes. The slopes are the same. Perpendicular lines have that opposite reciprocal slopes. And if neither of that happens, the lines that are neither parallel nor perpendicular basically have slopes that are not the same and they're not opposite reciprocals. So for number 1, it says, are the graphs of 4y equals -5x plus 12 and y equals 4/5x minus 8 parallel, perpendicular, or neither? So what we're going to do is we're going to identify the slopes of both of these lines and compare. So this line here is very easy. This is in slope-intercept form, so I can easily identify the slope. My m is 4/5. For the second line, the first one that they gave us, the 4y equals -5x plus 12, I can't identify the slope yet because to identify slope, we either need it in point slope or we need it in slope intercept. And this is neither of those formats. So we're going to have to get y by itself, which means I'm going to have to divide everything out by a 4. So we end up with y equals -5/4x plus 3. And now if I look at this, now this has a slope of -5/4. So what we're going to do is we're going to compare these two slopes together. So let's first check if they are parallel. Parallel lines mean they have the same slope. So is 4/5 the same as -5/4? Well, no, those are two different numbers. So since the slopes are not the same, it is not parallel. So now we check perpendicular. Are they opposite reciprocals? So the first thing we're going to check is, are they opposite signs? Yes, this guy is positive, this one's negative. The reciprocal part means, are their fractions flipped? So the red one is 4 over 5, and the green one is 5 over 4, which is this guy flipped over. So this example, these two lines are perpendicular. And it says explain your reasoning. So they are perpendicular because 4 over 5 and negative 5 over 4 are opposite reciprocals. That is what makes them perpendicular. Let's look at another example. Let's look at example number 2. So number 2 are the graphs of y equals negative 4, y minus 4 equals 3 parenthesis x plus 2, and negative 2x plus 6y equals 10, parallel, perpendicular, or neither. Explain your reasoning. So again, let's find the one that's easy. This first line is very easy to identify because that is exactly in point slope form. And for point slope form, our m is directly in front of the parentheses. So this guy has a slope of 3. The second line is not as easy to identify because the second line is in standard form, which we don't get anything from. So we need to change the standard form equation into slope-intercept by solving for y. So first we're going to add 2x to both sides to get y by itself, or start to get y by itself. So 6y equals 10 plus 2x. And then to finally get y completely alone, we will divide everything by a 6. So I can simplify these fractions. So 10 over 6 can simplify to 5 over 3, plus 2 over 6 simplifies to 1 over 3x. And so now my slope for this second line is 1 over 3. And now we compare. So parallel means the same slope. So 3 and a third are not the same number. So these are not parallel lines. Then opposite reciprocal slopes is how we get perpendicular lines. So I see that a 3 and a third are in fact flipped fractions, because if I make this guy a fraction, that's 3 over 1. And if I flip over 3 over 1, you end up with a third. However, we're missing this piece here. The opposite piece means that their signs are different from each other. So this was a positive, and this is also positive. So yes, these are reciprocals, but they're not opposite reciprocals. So these are not perpendicular either. So this is one of those cases where these lines are neither parallel nor perpendicular. And the reason is, because the slopes are not the same. The slopes are not the same. And they are not opposite reciprocals. That's what makes these neither. They're not the same slope and they're not opposite reciprocals either. Now let's talk about writing equations of parallel and perpendicular lines. And so we've done pieces of this before. We've already written equations with certain slopes and through certain points. So for number 3, a line passes through 12, 5 and is parallel to the graph of y equals 2/3 x minus 1. What equation represents this line in slope-intercept form? So what this is asking you to do is it's asking you to write an equation that represents the described line in slope-intercept form. So before we start, let's decide, what do we know about this new line that I'm creating? Well, I know that it has to pass through 12, 5. So I know that 12, 5 has to be on the line. I also know that it says it is parallel to the graph of y equals 2/3 x minus 1. And I know that when I see this word parallel, I know that that means that my slopes have to be the same. So if this y equals 2/3 x minus 1 is the old line that I'm comparing to, that means my new slope, the one that I'm creating, has to have the same slope as the old line. So the slope of the old line is 2/3. So to be parallel to that, my new slope also has to be 2/3. Well, now I have a slope and a point for my new line. So I can start writing this equation in point slope form. And so let's plug in what we have. So y minus y1, which is a 5, equals m, which is my 2/3, that's the new slope, times x minus x1, which is a 12. Now, this is the equation of a line. This is, and you may be able to leave it like this. This question, however, says it wants the answer in slope-intercept form. So I can't leave this the way it is because this is point slope. It's the wrong format. So we're going to have to change this guy into slope-intercept, which means we need to get y by itself. So I'm going to distribute out this 2/3. So 2/3 times x makes 2/3 x, and 2/3 times negative 12, if you need to, let's do that on the side. 2/3 times negative 12 over 1. Well, 2 times negative 12 is negative 24. 3 times 1 makes 3. And negative 24 divided by 3 makes negative 8. And then we need to drop down y minus 5. To get y completely alone, we need to add 5 to both sides of my equation. So y is equal to 2 over 3x minus 3. So this here is the equation of the line that is parallel to this one and goes through 12, 5. And yes, these are parallel because their slopes are the same and their y-intercepts are in fact different numbers. Pause the video, try number 4. And this is one answer you could have had for example 4. So because the question did not specify which format I needed my line equation to be in, we can leave it right here in point slope form. However, for some practice, we will continue to change this into slope-intercept just for some practice on our notes. So first, I knew I had to be parallel, so that means my new slope and the old slope needed to be the same number, and this was the coordinate that I needed to go through. Remember that minusing a negative changes it into a positive, so minus negative 6 is really a plus 6. So pause the video, practice changing this into slope-intercept form. And this is your slope-intercept form version. So 6 and negative 6 combine together to make 0, which we don't need inside our equation. Writing equations of perpendicular lines. So the process stays the same. Let's identify what we want our new equation to look like, and then we create the equation based on that information. So number 5, which equation represents the line that passes through negative 2, 4 and is perpendicular to the graph of y equals 1/3 x minus 1 in slope-intercept form. So I know that my new line has to pass through negative 2, 4. So that it has to be on the line for my new equation. And then I also know that I need to be perpendicular to the graph of y equals 1/3 x minus 1. And perpendicular lines have opposite reciprocal slopes. So if it said parallel, I would use the same slope, but since I want perpendicular, we're going to use opposite reciprocal slopes. So my new slope, my new m, well, let's see. Let's do the opposite part first. So opposite means change the sign. So since this is a positive slope, my new slope will be a negative number. And then the reciprocal part means flip your fraction over. So if I take 1/3 and I flip those numbers, you're going to get negative 3 over 1. Well, I can simplify that even further by just saying negative 3. So what we've done is we've created a line that is perpendicular using this slope, and I just have to make sure that it goes through this point. And the way we do that is by starting in point slope form. And so when we substitute the numbers we have, so y minus y1, which is the 4, equals my new slope. Make sure you're using the new slope and not the old one. So my new slope is negative 3. And then x minus x1, which is a negative 2. And again, make sure you're in the correct form. It says I want the answer in slope-intercept form, so we need to change this into y equals. First, I'm going to clean up this double negative here. So this double negative really changes to a positive. So y minus 4 equals negative 3 parentheses x plus 2. And now that we've kind of cleaned that up, let's get y alone. So let's distribute out this negative 3. And then to get y completely alone, simply add 4 to both sides. So y equals negative 3x minus 2. And so this is the line that is perpendicular to the one that was given and goes through negative 2, 4. Pause the video, try example 6. And this is what you should have had for example 6. So I know that these have to be perpendicular, so your slope needs to be an opposite reciprocal from negative 2. So the negative changes to a positive. And remember that whole numbers are fractions just over 1. And so when you flip around a 2, you end up with a 1/2. So start in point slope form here, and because this did not specify which format I wanted my line in, you could have left it right here in point slope form and it would have been perfectly acceptable. For practice, I have changed it into slope intercept, and it should have had y equals 1/2 x minus 1. So what happens if I compare my new line to an axis versus a different line? And so we can't quite follow the same process because we may not have a numerical slope. Remember that vertical lines have undefined slopes. You can't solve it the same way you would have the first time. So when you're compared to an axis, it's easier to draw a picture to get an idea of what this situation looks like. But first, let's remember that vertical lines are always x equals a number, and horizontal lines are always y equals a number. And now let's look at example 7. What is the equation of the line that is perpendicular to the y-axis and passes through the coordinate 2, 4? So I'm going to draw a little picture. So here's my axis. There's the y, there's the x. And I'm going to draw a picture. So I know that it has to pass through 2, 4. So I'm going to plot 2, 4. Here it is. 2, 4. And I know that I need to be perpendicular to the y-axis. So that's this axis. Well, remember that perpendicular lines cross at 90 degrees. In some way, shape, or form, they always cross at 90 degrees. So if you try to draw a line through 2, 4 that's slanted, well, that's not perpendicular because that's not 90 degrees. So that's not going to work. If I try to slant it down, that's not going to work either because that's not 90 degrees. The only way to make it perpendicular to an axis is to flip the direction of the axis. If I draw it this way, well, those don't even cross each other, so that's not perpendicular either. So the only way that I can get these perpendicular is by making this a horizontal line across the graph through that coordinate. This is the right angle that I need for perpendicular lines. So now that I have a picture, we're going to write the equation for that red line. So first off, I notice that this is a horizontal line. And I know that horizontal lines are y equals a number. So the equation for this is going to be y equals. Well, what is the y? All the y's are the same throughout that entire line, and so I'm going to use the point that I have. Y is equal to 4. So the graph of y equals 4 is perpendicular to the y-axis and goes through the coordinate 2, 4. Now, what if we do the second example 7? Below it, what is the equation of the line that is parallel to the y-axis? Well, so parallel to the y-axis and passes through 1, 3. So if I do the same idea, I'm going to create a t-chart. So here's my x-axis, here's my y-axis, and I want to go through the point 1, 3. So here's the coordinate that I want to go through. But this time I need to be parallel to the y-axis. Well, parallel lines never cross each other. So if I try to go draw the same direction I did last time, those lines cross right here. And so those are not parallel to each other. So I can't draw it slanted because that still crosses the y-axis, which means it's not parallel. So to draw a parallel line, I'd have to draw this guy up and down the same direction as my y-axis goes. Those two lines will never cross. This axis and this line are parallel to each other. So now that I have a picture of what's going on, I notice that this is a vertical line. And I know that vertical lines are always x equals something. So the equation for that red line will be x equals, and then again, all of the x's are the same along that line, so the x is equal to a 1. Pause the video, see if you can try both example 8s. And here's what you should have had for both example 8s. So what is the equation of the line that contains this coordinate and is parallel to the x-axis? So being parallel to the x-axis means I need to go in the same motion as the x-axis. So it's another horizontal line. So if you notice, this single horizontal line can be two things. This is parallel to the x-axis, but it is also perpendicular to the y-axis. So the same line can do two different things depending on what you are comparing it to. Same thing with number 8 on the bottom. Perpendicular to the x-axis means that I need to make a right angle with the x-axis, so it's a vertical line. And vertical lines are always x equals, and the coordinate runs through 3, 2.